Okay, welcome everyone. Hopefully you're all fine. We'll look at a few problems from the revision session for 131, and I included some questions on derivatives and chain rules, but I think that can be sort of exercise questions that you guys want to look at after we finish the session. But in this session, I just wanted to focus on related rates and some function related questions, because that's the main two types of questions that I received from everyone who was sending me their questions. So I decided to choose these because apparently that was the main concern for most of you guys. So we'll have a look at those. So let's look at question 3. It's telling us that a spotlight on the ground is shining on a wall that is 20 meters away, right? So if we were to draw this, let's assume that the spotlight is somewhere here, right? Let's call it S. And the wall, right? It's a wall, so is 20 meters away. Please mute yourself. It's 20 meters away. So this distance between the spotlight S and the wall, let's call it right, wall. So this distance here is 20 meters, right? And then next, it's telling us that if a woman, right, 2 meters tall, walks from the spotlight, right? So from the spotlight towards the building at a speed of 1.2 meters per second, right? How fast is the length of her shadow on the building decreasing when she's 4 meters from the building? Right, so if you were to imagine that the woman is, right, so let's just draw, again, this is just a caricature. So let's just draw that the woman is there, right? She's 2 meters tall, right? So that's a very tall woman. So 2 meters. So this distance here, so let's just draw. So this distance here from the top to bottom is 2 meters, right? So, and they're telling us that the woman is traveling towards the wall from the spotlight, right? At a speed of 1.2 meters per second, right? 1.2 meters per second. And they're asking us to find how fast the length of her shadow is decreasing. Her shadow on the building is decreasing when she's 4 meters from the building. So let's make some room at the bottom here. So if we were to okay, so right, so if we were to call the distance between the spotlights, right, where the spotlight is and where the woman is, let's call that distance x, right? And obviously we can call the y-axis, well, the length of the wall y, right? And it's in meters, right? They're both in meters. So If x is the distance between the spotlight and the woman, and y is the length of, oh, sorry, not the wall, but the length of the shadow of the woman, right, on the wall, right? We have that using related triangles, right? We have that 2, which is the height of the woman, right? 2 divided by the length of the shadow of the woman on the wall, right? Which is y. That is equal to the distance between the woman and the spotlight, which is x, divided by the distance between the spotlight and the shadow on the wall, right? Which is 20 meters. It's given to us, right? So here we're using similar triangles, right? So obviously now we have, if you multiply by y on both sides, right? Y and 20, then you have xy, right? So from that, oh, sorry. So from that, you have that xy is equal to 40, right? So since xy is equal to 40, just give me a minute, guys. Okay, so we have xy is equal to 40, right? Now, if we take the derivative, because if you guys remember, we can take the derivative on both sides in terms of time, right? Because we are looking at how the shadow is changing, right, over time, right? So we can take the derivative on both sides of this equality in terms of time. And if you do that, remember that x and y are both changing in terms of y. So if you take that, you can use the product rule. So when you take the derivative of xy in terms of time, you have that. First, you take the derivative of x in terms of time. So you have dx dt, right, multiplied by y, right, as a constant. That's the first side. And then you have x multiplied by dy dt, right? Sorry again for the handwriting. And then when you do that on the right hand side, obviously when you take the derivative of a constant, you have 0, right? So now that you have that, what you're looking for, right, is the change in the length of the shadow, right? So the length of the shadow is what we are focusing on here. And if you do that, then obviously what you're looking for now is dy dt, right? So from this equation, you have that dy dt, right, which is the change in the shadow over time, is equal to negative, right, if you solve for dy dt, negative y over x, right, multiplied by dx over dt, right? And now that you have that, right, you can go back to the original question now. So let's just make some room here. So the original question tells us that the woman is walking from the spotlight towards the building at a speed of 1.2 meters per second. And we said, right, if you remember, oh, what did that? Okay, I don't know what happened. We said, right, yeah, there it is. So the speed at which she's traveling away from the spotlight is 1.2 meters per second. So that's the change in x, right? So clearly we can see that dx dt is equal to 1.2, right? And the question is asking us that what is dy dt when x is equal to 4, right? When she's 4 meters from the building. So x is equal to 4. Oh, sorry. No, when she's 4 meters from the building, right? She's going towards the building. So at that point, x would be 20 minus the 4, 16. So she would have traveled already 16 meters, right? So our x will be the total distance from the building minus what she has left to travel, which is the 4 meters, right? So that's 16. So she has already traveled 16 meters on her way to the building. Now that we have that, the next thing that we need to find is y. Y when x is equal to 4, or 16. And we already have the relationship between x and y, which is x times y is equal to 40, right? So if you have x, y is just equal to the 40 divided by x, right? And since x is 16, you have 40 divided by 16. And that gives you, if you do the math, it gives you 2.5 meters. Right? So, oh. And now that we have everything, we can find what is dy dt, right? So dy dt is therefore equal to y, which is 2.5, right? So negative y, so negative 2.5, right? Divided by x, which is 16, multiplied by dx dt, right, which is 1.2. So 1.2. And when you do this math, you can find that it's equal to negative 0.1875 meters per second. Right, so, and really what this means is that it means that the shadow, the length of the shadow, right, which is y, on the wall, as the woman is walking towards the wall, is decreasing, right? Because that's what we're looking for, decreasing. That's what the negative means. It is decreasing at a rate of 0.1875 meters per second, right? So the question is asking us the rate at which it's decreasing. So the rate at which it's decreasing is just 0.1875. That's the final answer. Okay. Any questions here? All right. There doesn't seem to be any questions. Let me just okay, let's move on to the next question. So the next question is telling us that we have an airplane flying horizontally at an altitude of y equal to 3 kilometers and at a speed of 480 kilometers per hour, right? And that plane is passing directly above a person named Tulani on the ground, right? And they are asking us how fast is the distance z from Tulani to the airplane, right? Increasing 30 seconds later. So let's try to visualize this. So the airplane is somewhere in the air, right? So let's say that the airplane is represented by our dots here. Now, this person Tulani is somewhere on the ground, right? So let's say Tulani is somewhere here. So that's where she is. And they're telling us that the airplane is at an altitude of 3 kilometers, meaning that the distance, right? The vertical distance between where the plane is and the ground where Mrs. Tulani, Mr. or Mrs. Tulani is 3 kilometers. So that's 3 kilometers, right? And if we could represent the horizontal distance between the airplane and Tulani as x, we can just write it there. And now we have a triangle that looks like this, right? And we can call this distance d, right? Between Tulani and the airplane. And d is the distance that we are looking for, right? So, or we can call it z as well. Right, so they called it z, so let's call it z just for a better understanding. So let's call it z. And now we know that, right? So we know that the distance, so the speed at which the plane is going, right? So which we can call that v, right? So let me just erase this. So we can call the speed at which the airplane is going v. And that speed, right? If you think about it, the plane is flying on a horizontal axis up in the air, right? So that would be the change, right? The change in x over time. So that's the speed of the plane, right? And that is given to us as 480, right? 480 kilometers per hour. So we have 480 kilometers per hour. Right? So for consistency's sake, right? They're asking us to find the distance that the plane has traveled 30 seconds later. So if we were to transform this 30 seconds into hours, because we already have hours here, we need to be consistent with the units. So if we were to say t is equal to 30 seconds, right? That 30 seconds is just equivalent to, if you use the correct equivalence, you can have that is equal to just 1/20th of an hour, right? So we keep the consistency since the time is already expressed in terms of hours here. So now that we know that, we have a triangle, right? We can use Pythagoras theorem. Let's make some room here. So if we use the Pythagoras theorem, that tells us that x, right, x squared plus y squared is equal to z squared, right? And we are already given, right, the vertical distance between Tulani and the airplane, which is 3 kilometers, right? So since we're given that already, it just means that we have now x squared, right, plus 3 squared, which is 9, equal to z squared, right? So we can take the derivative now. We have our equation. We can take the derivative in terms of time, right? That's what we're looking at, time, on both sides of the equation. So if we do that, on the left-hand side, we have x squared. The derivative of that will just be 2x, right? dx dt. Remember, we are using here the chain rule. So dx dt. And the derivative of 9 is 0 because it's a constant, right? So that is equal to the same on the right-hand side, 2z dz dt. Right? So now that we have that, what we're looking for is dz dt, right? The change of z 30 seconds later. So we're looking for dz dt. Expressing this in terms of dz dt, we have that dz dt is equal to x over z, right? So the 2 cancels, multiplied by dx dt. So now we have our differential equation. Now, we know, right? So let's make some room first. So we know that we need to find what's at this time t 30 seconds. We need to find what is x, what is z, and what is dx dt to find the change in z over time, right? So what is x at t equal to 30 seconds, right? So we already know that, so we already know that dx dt is equal to 480 kilometers per hour, right? So x is changing at that rate. So when t is equal to 30 seconds, which is 1/20th of an hour, we have that we can substitute, we can multiply basically, right, dx dt by the time to find x. And therefore at t equal to 30 seconds, we have that x is equal to 480, right? 480 multiplied by the 1 over 120. 120. And obviously this gives us 4 kilometers. Right? So now we have x. Let's find now or z. Well, we already have y, we have x. We can use the Pythagoras theorem to find z, right, at that value. So z is therefore equal to the square root, right, of x squared plus y squared. X is 4, so that's 16 plus y squared, which is 3, so that's 9. 16 plus 9 is 25, so the square root of 25 is 5. 5 kilometers, right? So we have x, we have z. Now we need to find dx, and we already have dx dt, right? So that's 480. So we can find dz dt now. So therefore dz dt is equal to x over z, which is 4 over 5, 4 over 5, multiplied by dx dt, which is 480. So multiplied by 480. And if you do the math correctly, this should be equal to 384 kilometers per hour. So now we have the change in z over time. And we are asked to find z 30 seconds later, right? So all we have to do now is when t is equal to 30 seconds, we have that z is equal to 384 multiplied by 1 over 120. Right? I think that's the correct way, if I'm not mistaken. And if you do the math there, you'll find that that is equal to just 3.2 kilometers. So when time is equal to 30 seconds, the distance between Tulani and the airplane, this distance, the z distance, is equal to 3.2 kilometers, right? So yeah, that is it. Any questions?